Hello everyone. In this video, we are going to look at a previous exam paper and we're going to focus on the chapter of electrostatics. Without any waste of time, let's get right to it. The first question that we have, it says two identical insulated spheres, X and Y, subtended by threads from a ceiling, are held at a small distance apart as shown in the diagram below. So we can see on the diagram, we are having two spheres, X and Y, and then the X is positive and the Y is negative. So the statement continues to say, sphere X carries a charge of positive 4 times 10 to the power of negative 18 coulombs, while sphere Y has excess of 30 electrons. So now the sphere of Y is having excess of electrons. Okay, so the first question that we have, which is 10.1, they say calculate the magnitude of the charge on sphere Y. So now, if you have the number of electrons of a charge, you will be able to determine the charge. So you are going to use the following equation to say now, the charge is equals to the number of electrons multiplied by the charge of one electron. So for you to substitute and get the number of charges you have in that charge, you're going to say now the number of electrons is 30, and then now the number of charge in one electron is a constant. So you can determine that on your formula sheet. Then you will see that is negative 1.6 times 10 to the power of negative 19. So now you don't have to put this negative sign here because on the question, they have already told you that the charge of Y is a negative charge. So you just have to substitute or put in your calculator the number of electrons multiplied by 1.6 times 10 to the power of negative 90. And therefore, you already know that the charge will be negative charge, which is negative 4.8 times 10 to the power of negative 18 coulombs. So that is how you determine a charge if you have a number of electrons. You just substitute it here on the equation, and then remember now this is a constant. You can just substitute that. So if we move on, the statement says that the spheres are now released and they move towards each other. So 10.2, it says now, give a reason why sphere X and Y move towards each other. So these spheres here, they have opposite charges. So remember now, if you have opposite charges, we have a force of attraction between the charges. So we are just going to say now, opposite charges attract. So that is why they move towards each other, because they have opposite charges. Remember, if they had same charges, they were going to repel. So now they have opposite charges, so they attract. So that is how you would answer question 10.2. Let me just clean here so that we can continue answering here. We have another follow-up statement that says that the spheres are allowed to touch each other. After touching, they are moved away from each other. So remember that when the spheres touch each other, we are going to have transfer of electrons up until the spheres have what? Have the same charge. So that is what we know when the spheres come, they touch each other and move separate again. But now the question that follows here, which is 10.3, it says we must state the principle of conservation of a charge. So now a conservation or a principle of a conservation of a charge, it says that the net charge of a charge is going to remain the same in an isolated system, is the same in an isolated system. So now this means now if you have a net charge of, let's say now this one of positive 4 times 10 to the power of negative 18, the charge will remain like that if you have a closed system. But now once you bring the charges together, Now this becomes an open system. We are going to have a transfer of electrons. So the charges will change. But now in an isolated system, we are saying now the conservation of charges stays. It stays conserved. So now if we look at the last question that we have, which is 10.4, they say calculate the charge on each sphere after they have been separated. So now we are going to calculate a new charge that both the spheres will have after separate. So remember, to calculate a new charge, we say now the new charge is equal to what? To charge of x plus the charge of y, all divided by 2. So we're just going to substitute now the charge of x. Remember, you must put in the signs. This charge of x is positive 4 times 10 to the power of negative 18. But now the charge of y was calculated to be negative 4.8 times 10 to the power of negative 18. So we'll substitute that to say, okay, the charge of y is how much? Is negative 4.8 times 10 to the power of negative 18. Then we divide that by 2, and then we get the value of the new charge. So when we put that in our calculator, we will get that our new charge is equal to negative 4 times 10 to the power of negative 19 coulombs. So this will be the new charge after contact and separation. So we can continue now to answer the next question. The next question that we have, it says what? It says two small identical spheres, A and B, are subtended on a long silk thread as shown in the sketch below. The spheres carries a charge of positive 3 times 10 to the power of negative 6 and negative 2 times 10 to the power of negative 6 respectively. So the first question that we have, which is 10.1, it says which sphere has excess of electrons. So remember, the sphere that has excess of electrons is going to be a negative sphere, because electrons means negative charges and then protons means positive charges. So now if we answer the first question, which is 10.1, we're going to say what? The sphere B is going to be the one that is having excess of electrons. So now the next question, which is 10.2, they say now the two spheres are allowed to charge. Will electrons be transferred from A to B or from B to A? So remember, electrons are going to be transferred from the charges that has more negative charges. So they're going to move from B to A, because B has more electrons. It has excess of electrons, so it's going to share its electrons with A so that they become the same. They end up having the same electrons, hence the same charge. So this means what? Our electrons are going to move from what? From charge B to charge A, because charge B has excess of electrons. So now the next question, which is 10.3, they say now the spheres are now separated. Calculate the new charge. So remember, when the spheres come together and then they got separated, so the new charge is just going to be what? New charge is equal to the charge of A plus the charge of B, all divided by 2. So we're going to substitute the charges with their signs to say now the charge of A is positive 3 times 10 to the power of negative 6, plus the charge of B is how much? Is negative 2 times 10 to the power of negative 6. And then all this divided by 2. And therefore, we are going to get the new charge. So we are going to say 3 times 10 to the power of negative 6 plus negative 2 times 10 to the power of negative 6, all divided by 2. So the answer that we get here is going to be equivalent to 5 times 10 to the power of negative 7 coulombs. So the new charge is 5 times 10 to the power of negative 7 coulombs. So when we move on to the next question, which is 10.4, they say calculate the number of electrons transferred during the contact. So now remember, to calculate the number of electrons that were transferred, we first need to calculate the number of charges that were transferred. So remember, we're going to have the same number of charges that were transferred in charge A and charge B. It's just that the charges were transferred from A, and then, or maybe the charges were transferred from B, and then now the other one accepted those charges. So, but now to determine the number of charges, we are going to say now, okay, the number of charges that were transferred is just going to be what? The new charge minus any old charge, charge of A or charge of B. Remember now, you are going to get the same answer, but the difference is just going to be the sign that indicates whether we have gained electrons or lost electrons. So we're just going to say now the charge of A in this case. And therefore, we're going to substitute to say now the number of charges that were transferred is going to be the new charge. The new charge is positive because we got the answer as positive. So we are going to have what? We are going to have positive 5 times 10 to the power of negative 7 minus the charge of A, which is the old charge, which is 3 times 10 to the power of negative 6. And then we get the answer of what? Of the new, now the charges that were transferred. So it's going to be 5 times 10 to the power of negative 7 minus into 3 times 10 to the power of negative 6. And therefore now, the charges that were transferred is negative 2.5 times 10 to the power of negative 6. And therefore, this is going to be what? This is just going to be coulombs, is the number of charges. Remember, I said that if you get the number of charges to be negative, what does this mean? It means that the charge that we have used here, it has gained electrons. And then if you look at the question that we have answered in a 10.2, we said electrons are going to move from what? From B to A. So do you see now A has gained electrons because it has less electrons. So if we got this incorrect, by just calculating the charges that were transferred, we can also determine now which one gained or which one has lost. So now remember, it doesn't matter now if you have calculated using a charge of A or a charge of B. You are still going to get the same answer, but now different signs. So but now if you want the number of electrons that were transferred, you are going to say now, I have now the number of charges that were transferred. So I'm just going to say the number of electrons will be the charge that was transferred divided by the charges of one electron. So this is just going to be n equals to, so the charges that were transferred is 2.5 times 10 to the power of negative 6, all divided by this thing which is a constant. We're just going to put it as negative, or you can put it as positive as it is. It really doesn't matter. So you can say 1.6 times 10 to the power of negative 19. And therefore, when we substitute this in our calculator, we are going to get that the number of electrons that were transferred, let me just say 1.6 times 10 to the power of negative 19. And then we get that they are 1.5625 times 10 to the power of 13 electrons that were transferred. Okay, so that is all for electrostatics. I think if you understand these two questions, you will be able to answer the exam, unless you have some theoretical problems. Otherwise, thank you very much.